You ever wonder why some software is just a dream to use, while other apps make you want to throw your computer out the window? Well, the secret isn't always in the code. It's in the plan that was made long before a single line of code was ever written. Today, we're diving into that plan, the blueprint for our digital worlds.
I mean, we've all been there, right? You're staring at that spinning wheel of death, clicking a button that does absolutely nothing, or you're just totally lost in some confusing menu. It's a universal pain. But what if I told you the problem didn't start with the programmer, but with the idea itself, way back at the drawing board? And that is the big secret we're digging into today. The success or failure of a piece of software is often decided before the building even begins. It all comes down to the quality of its blueprint, what the pros call requirements. These are the instructions that tell the developers what to build and, just as critically, how well it needs to work.
So here's our game plan for this explainer. We'll start with the big picture, the blueprint itself. Then we'll break it down into two key parts, what the system is supposed to do and how well it's supposed to do it. We'll look at how a simple idea gets turned into a rock-solid command, and finally, how to connect all the pieces to make sure nothing gets missed. All right, let's dive in. So where does this all start? Well, the actual discipline of creating this blueprint has a name, requirements engineering. Seriously, think of it like being an architect for the digital world. You're laying a solid foundation so the whole skyscraper doesn't come tumbling down later.
Now, the very first part of any blueprint describes the building itself. The rooms, the doors, the windows. In software, that's the features, the buttons, the core purpose of the app. And these are called functional requirements.
A functional requirement, or FR for short, is basically a direct order. It says things like, the system shall calculate the total, or the system shall send a confirmation email. It's the big to-do list for the software. For example, a good FR would be something like, when the user clicks Add to Cart, the system shall update the shopping cart icon with the new item count. It is all about the what.
And let me tell you, getting this what right is everything. Clear FRS are like a contract. They make sure the business folks, the designers, and the coders are all building the exact same thing. They stop confusion in its tracks, they literally shape how the app is built, and they let you make realistic plans. Without them, you're just guessing, and that's a recipe for disaster.
But, a feature that just technically works isn't really enough, is it? Knowing what to build is only half the battle. Just as important is defining how well it needs to do its job. And this brings us to the second and often forgotten part of our blueprint, non-functional requirements.
A non-functional requirement, or NFR, is all about the quality, the vibe, the experience. It doesn't describe what a feature does, it describes a characteristic. Think of words like fast, secure, reliable, or easy to use. An NFR might say, the login page shall load in under 2 seconds, or the system must be able to handle 500 users at the same time.
And this right here, this quote just nails it. It perfectly shows why NFRs are so important. A system can do its job correctly, it completes the transaction, checking off that functional requirement. But if it takes an eternity to do it, nobody's going to use it. The NFR is what makes a feature not just functional, but actually usable in the real world.
So, to put them side by side, FRs are about what the system does, NFRs are about how it does it. You test FRs by running the app to see if the feature works. You verify NFRs with things like performance tests, security scans, and user feedback. You absolutely need both to build something great.
Okay, so we get it. We need both types of requirements. But where do they come from? I mean, how do you get from a vague idea in a meeting to a crystal clear, testable instruction that a developer can actually build? Well, that's the journey from a simple wish to a concrete command.
It's really a 3-step process. First up is elicitation, which is just a fancy word for listening, really. It's about talking to people, running workshops, and just observing to figure out what users actually need. Next, you analyze all that raw info and turn it into something that makes sense. And then, the really tough part, prioritization. Because you can't build everything at once, so you have to decide what matters most. And for that, there's a fantastic tool called the Moscow method. It's a super simple way to sort your features. You've got your must-haves, the absolute non-negotiable stuff, then your should-haves, important but maybe not for day one, could-haves are your nice little extras, and maybe most importantly, you have your won't-haves, the things you all agree you are not building right now. This is your shield against endless feature requests. And here's where it gets really smart. Moscow isn't just a to-do list, it's a risk management strategy. The best practice is to make sure your must-haves take up no more than 60% of your total effort. That leaves the other 40% as a built-in buffer. If things take longer than expected, you can drop a should or a could feature without the whole project failing. It's like building a safety net right into your plan.
Okay, once you know what to build, you have to write it down perfectly. But human language is messy, right? It's ambiguous. So to fix that, pros use a simple little template called EARS. It forces you to be clear. For instance, an event-driven requirement always starts with, when this specific thing happens, the system shall. This simple structure kills ambiguity.
And here it is in action. Look how beautifully clear that is. We have the exact trigger, selecting the option, and clicking the button. We have the precise response, retrieve and compile transactions from the last 24 hours. There is zero wiggle room there. The developer knows exactly what to do, and the tester knows exactly what to check. That's how a wish becomes a command. So, we've got our pristine, prioritized blueprint, but how do we make sure the finished building actually matches the plan? This last part is all about connecting the dots and making sure everyone stays on the same page from beginning to end.
The magic word here is bi-directional traceability. It sounds complicated, but it's just a two-way street. Forward traceability means you can pick any requirement on the blueprint and follow its thread all the way to the exact piece of code that builds it. And backward traceability means you can point at any feature on the screen and trace it all the way back to the original business need that it solved. Nothing gets built for no reason.
And this is the tool that makes it all possible. The Requirements Traceability Matrix, or RTM. This is the project's command center. Each requirement gets its own row, linking it to who asked for it, how important it is, how it's being tested, and whether it's done or not. It's the ultimate source of truth for the entire team.
And throughout this whole journey, we're constantly checking our work by asking two different but equally vital questions. The first is verification, which asks, are we building the product right? This is about checking the blueprint itself for mistakes before we start building. The second is validation, which asks, are we building the right product? This is testing the actual app to make sure it solves the user's problem. You gotta have both.
So to wrap it all up, what's the bottom line? First, great software starts with a great blueprint, and that means having both functional and non-functional requirements. Second, prioritizing with a tool like Moscow isn't just about making a list, it's about managing risk. Third, using precise language like the ERS template saves you from a world of confusion. And finally, traceability is the glue that holds it all together and ensures everyone is accountable.
So I'll leave you with this thought. The next time you're stuck on a slow website or wrestling with a confusing app, just pause for a second. And instead of blaming the coder, maybe ask yourself, what did the blueprint for this thing look like? Was it a clear vision from the start, or was it a mess from day one?